Welcome to TuRight. In today's video, we're going to learn about why did Thomson and Rutherford's atomic model failed. Thomson atomic model is the simplest model of an atom, showing the arrangement of electrons and protons. In this model, the positive charge of an atom is evenly distributed in a sphere and negative electrons are embedded in it. It is also called the plum pudding model. In the year 1911, Ernest Rutherford, along with Heinz Geiger and Ernest Masterton, conducted a series of experiments with the aim of exploring the structure of an atom. Rutherford's scattering experiment. The experimental setup consisted of a piece of radium, which is a radioactive metal, placed in a lead block. The lead block had a slit to allow only a narrow beam of alpha particles emitted by the radioactive radium to pass through. The alpha particles escaping from the narrow slit were directed to a thin gold foil of a thickness of approximately 100 nanometers. A movable circular screen coated with zinc sulfide was placed around the gold foil. The alpha particles produced by the radium escaped through the slit, struck the gold foil and got scattered. The scattered alpha particles were detected by the zinc sulfide screen in the form of light flashes or scintillations. Different portions of the screens were then examined to determine the deflection pattern of the alpha particles. It was observed that most of the alpha particles remain undeflected and pass through the foil. A few alpha particles got deflected through small angles. And hardly any alpha particles got deflected through a large angles or came back with the deflections of 180 degrees. These observations did not hold true to Thomson's atomic model, where it was expected that the positively charged alpha particles would pass through the weak electric field largely undeflected or slightly deflected. Thomson atomic model was discarded since it failed to explain Rutherford's observations. Based on the observations, Rutherford concluded that there must be a large empty space within the atom, since most of the alpha particles pass through the gold foil without any deflection. Some alpha particles are deflected to certain angles, which means there is a heavy positively charged mass present in the atom. This positive mass must be concentrated in a very small space within the atom. Since only a few alpha particles showed large deflections, the bouncing back of very few alpha particles with a deflection of 180 degrees indicated a direct collision with the positively charged mass of the atom. Later, Rutherford termed this positively charged mass as the nucleus and proposed it to be located at the center of the atom. Thomson atomic model explained the overall neutrality of an atom. Its assumption that the total mass of an atom is uniformly distributed all over the atom was inconsistent with some of the experimental results. The atom, as described by Rutherford's model, was expected to be unstable because an electron move in a circular motion should radiate energy continuously. So it should follow a spiral path and fall into the nucleus. Hope you've liked this video. If you've liked this video, subscribe to this channel and hit the bell icon so that you do not miss on any of these videos. Keep learning. Here in TuRight, we believe that every child is unique, and to help you more with this, we have come up with a free counseling session to help you succeed. Are you worried about scoring less marks in exams? Or are you worried about focus, study hours, consistency? Then all you need is a free counseling session from us. To book a free counseling session with us, all you need to do is type www.turight.com. That's right, TuRight.com. And as you enter into the website, you get a window where it is being written as free session. You just need to enter your details and you're all set to go. Not only that, TuRight also helps you in public speaking, communication, and makes you unique and different from others. Register today to get started.